Have you ever wondered how a tiny model car can perfectly capture a real one? Or how a recipe can go from serving 2 people to 20 without turning into a complete disaster? Well, the answer is this kind of hidden mathematical language, this secret code that runs everything from art to engineering. Today, we're going to crack that code. We're talking about ratios.
Okay, so picture this. You found the most amazing pastry recipe. It calls for 500 grams of flour and 250 grams of butter. It's delicious, it's perfect, but it only serves 2 people? Now, what happens when you want to make this for your whole family? How do you multiply those ingredients without creating an absolute mess in the kitchen?
And here's the cool part. This isn't just about baking. The exact same mathematical secret that saves your pastry also lets a paint your mix the perfect shade of purple every single time. It's like this hidden recipe for consistency that's all around us, no matter the scale. So how do we actually do it? How do you scale things up or down flawlessly every single time? Well, the answer, and really the hero of our story today, is the ratio.
All right, so let's get right to it. What exactly is this powerful tool? Well, at its core, it's actually surprisingly simple.
Seriously, that's it. A ratio just compares values. It's a simple statement that says, for this much of thing A, you need this much of thing B. It's all about the relationship between the numbers.
And in math, we write this relationship using a colon. So for our pastry, we're just comparing the amount of flour to the amount of butter.
And this brings us right back to where we started. The ratio of flour to butter is 500 to 250. This is our core instruction, right? The secret code of our recipe. But you gotta admit, it's a bit clunky, isn't it? We can make that so much simpler.
And that brings us to an absolutely crucial skill, simplification. This is where we take those kind of clunky numbers and we turn them into something elegant, easy to understand, and way more powerful. Think of it this way. Instead of saying you need 500 grams of flour for 250 grams of butter, what if you could just state the most basic version of that relationship? That's exactly what simplifying does. It just boils everything down to its essence. Let's try a new example. Say a painter is mixing 4 liters of red paint with 2 liters of blue. So the ratio is 4 to 2. How do we find the core recipe for this perfect purple? It's just a simple 2-step process. First, we find the highest common factor, or HCF. Now that's just a fancy way of saying we find the biggest number that divides evenly into both parts of our ratio. So for 4 and 2, the biggest number that fits into both is, well, 2. Then we just divide both sides by that number.
And there you have it. 4 divided by 2 is 2, and 2 divided by 2 is 1. The simplified ratio is 2 to 1, and that means for every 2 parts of red paint, you need exactly 1 part of blue paint. Now you can make a single drop of this purple or an entire swimming pool full of it.
Okay, so you're getting the hang of this. You're simplifying ratios like a pro. But there's a classic trap you have to watch out for. This is where most people get tripped up. So take a look at this. Simplify 30 to 4. Now, your first instinct might be to just, divide both by 2 and call it 15 to 2, right? But hold on a second. Here is the trap. We are comparing millimeters to centimeters. Those are not the same unit of measurement. It's like comparing apples and oranges. You absolutely cannot simplify a ratio until you are comparing like with like.
So the golden rule is this. You have to convert first. We all know there are 10 millimeters in a centimeter, so 4 centimeters is just 40 millimeters. Now we have a fair fight, 30 millimeters to 40 millimeters. And once the units are the same, then we can simplify. We can divide both 30 and 40 by their highest common factor, which is 10, and we get our true, correct ratio, 3 to 4. And let me tell you, that is a world of difference from 15 to 2.
All right, one last challenge for you. You've handled whole numbers, you've dodged the units trap. So what happens when our old friend, the decimal point, decides to show up?
Now, looking at this, you might feel a little bit stuck. I mean, how are you supposed to find a common factor when a decimal is involved? Well, the trick is, you don't. The trick is to get rid of the decimal first. Here's how you do it. To get rid of the decimal, you just multiply. Since 2.4 has 1 decimal place, we're going to multiply both sides of the ratio by 10. This keeps the relationship between the numbers exactly the same, but it gives us nice, clean, whole numbers to work with.
Let's see it in action. Multiply 2.4 by 10, you get 24. Multiply 4 by 10, you get 40. So now our ratio is 24 to 40.
And from here, it's easy. We just simplify like we did before. The highest common factor of 24 and 40 is 8. Divide both sides by 8, and you get the beautiful simple ratio of 3:5. And there you have it, your complete ratio toolkit. You now know that a ratio is just a simple comparison, you know how to simplify it to find its core essence, and you know the 2 golden rules. Always match your units and get rid of any decimals before you start. You're ready for any ratio the world can throw at you.
So, you've cracked the code. From the screen you're watching on, to the fuel mix in a rocket, all the way to that perfect cup of coffee. Ratios are everywhere, just quietly keeping our world in proportion. So the real question is, what are the hidden ratios that define your world?